Welcome to this video. This is an introduction to sequences and series. This is aligned with the Mathematics Analysis and Approaches Standard 1.2 and 1.3. So a sequence is a list of numbers written in an order according to a certain rule. So let's check out some examples. So the first example we see, it goes from 7 to 5 to 3 to 1, and then this ... means the pattern continues on forever. Well, clearly we can see we're subtracting by 2 each time, so that's what defines our sequence. That's the rule. On this next one, we've got 2, 4, 8, 16. So we can see that each time we're actually multiplying by 2. And the last one we see goes from 1, 3, 9, 27. And this one is also multiplying, but this time by 3. So sequences can be finite, meaning they stop, or they can be infinite or infinite, meaning they go on forever. And we can actually represent the entire sequence by something called a general term, UN, or sometimes it's written as UR, and we're going to discuss that more in a second. Now, a series is just a sequence where all the terms are added together. So we actually represent this using a special notation called sigma notation, which looks kind of like a 3 or an E. Now, you've got some important pieces here. You've got on the bottom whatever you start with. So it's going to be naming a variable. Sometimes it's an N, sometimes it's an R, even sometimes it's an I. It doesn't matter as long as it matches the variable on the inside of the notation. That's our starting number, and it could be any number, but in this case we're going to start with 1. And it's actually always going to be a natural number, a whole number. And then on top, that's the last value, or when we stop the series. On the inside tells us the formula. So in this case, since it's 2n, the first one would be 2, and then because our starting value is 1, so 2 times 1, that's where we get this here. And the sigma means plus, so we're going to add the next term. Well, 1 after that is 2, so we get 2 times 2. And so on, we continue the pattern, and we stop at 6. So this is a finite series because it stopped. Sometimes you'll see on top of the sigma will be infinity, which means it goes on forever. So when you write it out, you're going to have to put the ellipse, the ... All right, for each of the following, we're going to write the first 3 terms of the sequence. So we're given the general term here, and we're given our formula. This little notation, R, is an element of this Z plus just means positive integers. So keep that in mind whenever you see a Z that's integers, and because it has a little plus, that means it's positive integers. So we're going to do R as 1, 2, 3, and of course this goes on forever, but we're only going to do the first 3. So that will be 5 times 1 minus 2, then 5 times 2 minus 2, and 5 times 3 minus 2. We can simplify this. 5 minus 2 is 3, 5 times 2 is 10, 10 minus 2 is 8, 5 times 3 is 15, minus 2 is 13. So these are the first 3 terms of this sequence. Let's try the next one. Again, our numbers for R are going to be just the positive integers. So we plug this in, we get negative 1 to the 1th power divided by 1 squared is our first term. Then negative 1 to the 2nd power divided by 2 squared. And then lastly, negative 1 to the 3rd power divided by 3 squared. So this will simplify to negative 1 to the 1th power is just negative 1, and the divided by 1 squared is 1. Negative 1 squared actually turns it positive, and so it becomes positive 1 divided by 2 squared is 4. And then negative 1 to the 3rd power, it's an odd power, so it's going to be a negative 1. All that's over 3 squared, which is 9. So whenever you see that you have alternating terms like this, positive, negative, you're most likely going to have this negative 1 to the R power, or R minus 1 power, in your formula. All right, for each of these sequences, we're going to try and find the general term. Now this is going to get a little bit tricky, but I'll teach you the general strategy that will help you each time. Notice that on this first one, we can see that it's growing by a constant number each time. So if it's growing by a constant number or subtracting by a constant number each time, your general series, your general term is going to be of the form A times R plus B. Now your A is going to be whatever you're adding or subtracting by each time. So in this case 5. So UR is going to be 5R plus B. Now to figure out b, we notice that the first term is 2. So if I do 5 of 1, because that would be the first term, plus b, it has to equal 2. Well, that would mean b is negative 3. And we have our general term. So it's going to be UR equals 5R minus 3. Now the other type of equation you're going to see, the other type of sequence, is whenever you're multiplying by a constant each time. So this time we're multiplying by 2. If it's multiplying or dividing, because dividing is just like multiplying, it's going to be of this form. UR equals A times B to the R power. We've got an exponential. So b is going to be whatever we're multiplying by. So in this case, UR equals A times 2 to the R. And to figure out a, we did what we did in the first example to figure out b. So we're going to say a times 2 to the 1, because that would be the first term, has to equal 5. That would imply that a equals 5 over 2, or 5 halves. So then our general term is going to be UR equals 5 over 2 times 2 to the R power. Okay, on this one we're going to write the first 5 terms of each of the following series. So the series starts on the one on the bottom, which in this case is 1, and ends at the top, which is 10, but we're only writing the first 5 terms. So our first term is going to be 1 times 1 minus 1, which is 0, plus the next term, 2 times 2 minus 1, which is going to be 2 times 1, which is 2, and then the next one's going to be 3 times 3 minus 1. Well, 3 minus 1 is 2, 3 times 2 is 6, plus 4 times 4 minus 1. 4 minus 1 is 3, 4 times 3 is 12, and then lastly 5 times 5 minus 1. 5 minus 1 is 4, 5 times 4 is 20. And so these are the first 5 terms of this series. Let's try the next one. Notice this one goes to infinity, so you could write them all out, but we're not going to do that. We're only going to write the first 5 terms. So this will be 1 plus 1 over 2 times 1 minus 1, and that's going to be 1 plus 1 is 2, 2 times 1 minus 1 is 1, so then plus 2 plus 1 over 2 times 2 minus 1, that's going to be 3 over 3, and then the next one's going to be 4 over 5, and then 5 over 7, and then 6 over 9. Oh, and these are added together. Okay, last example, we're going to practice writing each of these series in sigma notation. So this first one, notice that it's growing by 8 each time. We're adding 8. So it's going to be of the form A times R plus B. And A is going to be 8 because that's what we're growing by each time. So we've got 8R plus B. Now remember the first term, when we plug in 1, has to equal 3. So that will help us figure out what B is. B must be negative 5 because 8 minus 5 gives you 3. So you can write your sigma notation starting at 1, and then there's 1, 2, 3, 4, 5 terms here. And it's going to be 8R minus 5. And I'm going to go ahead and put parentheses. Okay, let's try this next one. Now notice this one is actually multiplying by negative 1 each time. So it's going to be multiply, of the form A times B to the R. And I already know B, it's going to be negative 1, because that's what I'm multiplying by each time. Let's figure out what A has to be. Well, I know A times negative 1 to the R has to equal positive 1, because that's the first term. Excuse me, I'm supposed to have a 1 right here, because that would be the first term. Well, that would mean that A had to be negative 1 as well. So we know our series is going to be the form R equals 1 to, notice the ellipse, so infinity of negative 1 times negative 1 to the R power. Alright, that's it for this lesson. Now go ahead and try some practice on your